அடுத்ததாக யூனிட் 3 in your syllabus carboxylic acids. முதல்ல phenol பார்த்தோம், OH group attached to the phenyl group. Then we saw carbonyl compounds where the CO group is attached to either 2 hydrogens which is formaldehyde, 1 hydrogen and 1 alkyl group which is acetaldehyde or propionaldehyde, etc. If both the groups are alkyl groups, they are called ketones. Propanone was the first member of the series. Now the carboxylic acids are different from these compounds. Instead of having only OH group or CO group, it has in the functional group both CO and OH. This is carboxylic acid. Now let us see how this looks like. This is the carboxylic acid group. Actually the bonding is like this. This group is bonded like this. C double bond O, and to the same carbon OH group is attached. So it is a combination of both CO group and OH group. அது ஒரே கார்பனில் CO group double bond, another single bond OH இருக்கு. இதுதான் carboxylic acid உடைய functional group. When you say carboxylic acid, in your mind you should be able to visualize this structure, R CO OH. This R can be alkyl or aryl group. The carboxyl group வந்து it can be attached to a long carbon chain. Historically in the compound வந்து alpha, first carbon was called alpha after the carboxyl group. The second carbon is first carbon is carbon of the carbonyl group, second carbon is called alpha, third is beta, fourth is gamma, 5 is delta. This was the nomenclature முன்னாடி எல்லாம் யூஸ் பண்ணது. இப்போ வந்து the compound is named like this 1 2 3 4 5. இங்கே ஒரு substituent இருந்ததுனாக்க methyl group இருந்ததுனாக்க 2 methyl, let us say this bond is not there, this is a derivative of acetic acid, then it will become propionic acid. Longest chain is named 1, இங்கே ஒரு methyl group இருந்தால் 1 2 3 carbon, that is derivative of propane, and you have the COOH group, it is called oic acid. Propane, leave the E and add oic acid, called propanoic acid. Now these are some of the carboxylic acid, the aliphatic carboxylic acid. இதில் வந்து 3 கார்பன் இருக்கு. சென்ட்ரல் கார்பனில் புரோமின் இருக்கு. ஃபர்ஸ்ட் கார்பனில் கார்பாக்சில் குரூப். எப்பொழுதும் கார்பாக்சில் குரூப் இருந்தாக்க அதுதான் ஃபர்ஸ்ட் கார்பன், நம்பர் 1 கார்பன். தி அதர்ஸ் ஆர் கிவன் நம்பர் 2, நம்பர் 3 டிபெண்டிங் அப்பான் தி செயின். இங்கே வந்து ரெண்டாவது பொசிஷனில் புரோமின் இருக்கிறதுனால இட்ஸ் கால்டு 2-bromo propionic acid, propanoic acid. Propanoic acid, propane, leave the E, and oic acid. This is called propanoic acid. And இந்த மாதிரி காம்பவுண்ட் இருக்குது. இதில் செகண்ட் கார்பனில் CH3 குரூப் இருக்குது. தேர்ட் கார்பனில் Cl CH2. Cl is attached to the third carbon. So this is 3-chloro 2-methyl propionic acid. So இங்கே 3-chloro this should be 3-chloromethyl. This is 3-chloro 2-methyl propionic acid. The chlorine is on the third carbon atom. இந்த காம்பவுண்ட் பார்த்தீங்கன்னா இதில் வந்து சென்ட்ரல் செகண்ட் கார்பனில் 2 methyl குரூப் இருக்குது. This is 2,2 dimethyl propionic acid. ரெண்டு ஒரே பொசிஷனில் இருந்ததுனாக்கா you add the same 2, 2 dimethyl propionic acid. Here in the second carbon you have an amino group, it's 2 amino propionic acid. And this is, there is a double bond between second and third carbon, but there can be only between second and third carbon, therefore on the number specify பண்ணோம்னா this is called propenoic acid. The double bond is indicated by En, propenoic acid. Its also common name is acrylic acid. This compound is oleic acid. In the long chain carboxylic acids are called fatty acids. The fatty acids, in the acids எல்லாம் usually obtained in the form of oil or fats, where in the carboxyl group வந்து glycerol ஓட esterify பண்ணுறது. That is glycerol this is 1,2,3 trihydroxy propane. So this is compound, 3 hydroxyl group இருக்கு. When you acidify with acid, you can either have the same acid, you have the oleic acid 3 times. இதை வந்து sodium hydroxide hydrolyze பண்ணி அப்புறம் neutralize பண்ணாக்க HCl ஓட you get the acid. This is one of the common acid found from oils or fats. These are present as esters in oil and fat. That's why it's called fatty acid. The oleic acid contains 1 plus 7, 8, 9, 10, 17, 18. They usually have even number of carbon atoms. And they have either 1 double bond or 2 double bonds or 3 double bonds. The oil the double bond இருந்தாக்க they are easily cleaved in the body when you have them. If you have a saturated fatty acid, no double bond is there, they lead to formation of cholesterol. Body la cholesterol jaasti aayi heart la deposit aayi, that is responsible for heart attack or heart problems. இந்த மாதிரி டபுள் பாண்ட் இருந்ததுனாக்க இந்த டபுள் பாண்டில் ரியாக்ஷன் ஏற்பட்டு இந்த கொலஸ்ட்ரால் ஃபார்மேஷன் ஏற்படாது. அதனால் the double bond இருக்கிற oil is preferred. You will all know that these fatty acids, the unsaturated fatty acids are commonly recommended, especially heart problem இருந்தாக்க you should not take oils or fats such as saturated fatty acids. This is the IUPAC name. The double bond line usually cis double bond. Hydrogen and hydrogen are on the same side. The 2 alkyl groups are on the same side. This is cis 9 octadecanoic acid. Octadecanoic, the octa is 8, decan is 10, so it is 18 carbon atom called octadecanoic acid. The next is cyclohexane carboxylic acid. This is a cyclohexane ring. This is C6H12. If you substitute one of the hydrogens with the carboxylic acid group, it becomes C6H11COOH. So this is cyclohexane carboxylic acid. If you go to aromatic carboxylic acid, you have the simple compound is benzoic acid. benzoic acid. In the naphthalene ring, if this group CH2COOH is attached, this is named as 2, that is the position of attachment of the acetic acid group with the naphthalene. It is attached at the 2 position, 2,2-naphthyl acetic acid. So, this is the name of this naphthyl acetic acid. This is 2-benzyl 2-methyl propionic acid. There are 3 carbons. At the 3rd carbon should be 3-benzyl. Benzyl 2-methyl propionic acid. That's correct. This is 2-benzyl. At the 2 position, you have the benzyl group, 2-methyl propionic acid. And here, just like before we saw that acrylic acid, you have a double bond. This is benzene ring. This is 3-phenyl propenoic acid, showing the double bond. Propene is the ending for the double bond. முன்னாடி ஃபீனாலில் வந்து இந்த மாதிரி டைமர் ஃபார்மேஷன் விச் இஸ் ரெஸ்பான்சிபிள் பாய்லிங் பாயிண்ட் இன்க்ரீஸ் ஆகிறதுக்கு இந்த ஹைட்ரஜன் பாண்ட் மூலமாக டைமர் ஃபார்மேஷன் வாஸ் ரெஸ்பான்சிபிள். இந்த கார்பாக்சிலிக் ஆசிட் இன்னும் மோர் டைட் dimer bond is formed. This oxygen of the carboxyl group, the double bonded oxygen, has a hydrogen bond in the hydrogen oda, and the double bond oxygen in the hydrogen oda. So, 2 molecules, this is the COOH one molecule, this is the COOH another molecule, they form tight dimer, and usually these are very high boiling liquids or solids. Now, we will look at manufacture of carboxylic acids. Carboxylic acids வந்து ஹைட்ரோகார்பன்லேருந்து ப்ரிப்பேர் பண்ணலாம். You must use oxygen in the presence of catalyst. The catalyst ஓட oxidize பண்ணாக்க you get acetic acid. This CH3 group becomes COOH. And more easily acetaldehyde, aldehyde இருந்ததுனாக்க அதை oxidize பண்ணுறது much easier. Oxygen and catalyst you form acetic acid. A more modern method of forming acetic acid, taking methanol, reacting with carbon monoxide in the presence of rhodium plus iodine, insertion of carbon monoxide. The carbon monoxide goes in between here and forms CH3COOH. So, rhodium catalyst in the presence of iodine produces this insertion of carbon monoxide, அதிலிருந்து acetic acid வருது. We have just mentioned this hydrolysis of oils and fats. Oils and fats are triglycerides. 3, this is the glycerin group. The oxygen is esterified with fatty acid, where the N can be always even, the total number of carbon is even. CH3CO ரெண்டு போச்சுனாக்க இந்த CH2 groups are even numbered, and இதை hydrolyze பண்ணாக்க you get glycerol. This is the byproduct. In the fatty acids எல்லாம் இந்த மாதிரி 3 molecules of fatty acid will be formed, CH3 CH2N times COOH. இந்த fatty acids எல்லாம் they are very useful compounds, especially in the paint industry. You can form waxes. The salt எல்லாம் ஃபார்ம் ஆச்சுனாக்க வெவ்வேறு மெட்டலில் they are very useful compounds. Now, preparation of carboxylic acid, those are manufacturing methods. Large quantities வேணுனாக்க அந்த மெத்தட்ஸ் எல்லாம் யூஸ் பண்ணோம். Small quantities laboratoryயில் ப்ரிப்பேர் பண்ணோம்னாக்க these methods are used. One is oxidation of primary alcohol, RCH2OH in the presence of KMnO4 and KOH, alkaline permanganate will give RCOO minus K plus, neutralize it with H plus, you get RCOOH. So, primary alcohols can be oxidized to acid. We have seen earlier secondary alcohols on oxidation give ketones. இந்த ஆல்கைல் பென்சீன்ஸ் ஆக்சிடைஸ் பண்ணாக்க KMnO4 OH minus or dichromate and sulfuric acid, you get carboxylic acid. The long chain இருந்தாக்க ஒவ்வொரு கார்பனாக it will digest it and come to this carboxyl group. So if R is methyl or ethyl, you get the same carboxylic acid. In our methods, carbonation of Grignard reagents. The Grignard reagent was discovered by a chemist by name Victor Grignard. This is prepared by taking an alkyl halide in the presence of magnesium and dry ether. The ether should be very dry. Usually in the ether dry பண்ணுறதுக்கு sodium wire யூஸ் பண்ணுறது. Sodium metal is very reactive to water. So அதான் கொஞ்சம் water இருந்தாக்க அது it will react with it, remove the water from the solvent. சோடியம் ப்ரெஸ்ன்னு இருக்குது. அந்த சோடியம் மெட்டலில் போட்டு ப்ரெஸ் பண்ணாக்க சும்மா இது மாதிரி த்ரெட் மாதிரி வரும் சோடியம். அதை வந்து இந்த ரியேஜெண்ட்டில் போட்டாக்க ஈத்தரில் போட்டாக்க அதில் இருக்கிற வாட்டரெல்லாம் ஃபுல்லி will be removed, it will get dry ether. You can distill it or just decant it. அது மெக்னீசியத்தோடு அந்த ஈத்தரில் ரியாக்ட் பண்ணாக்க you get RMgX. This is called the Grignard reagent. The Grignard reagent carbon dioxide which is in the form of dry ice. This carbon dioxide, I will put it in bracket. Dry ice is when you cool carbon dioxide under high pressure. அது வந்து லிக்விட் போகாமல் டைரெக்டாக சாலிட் ஆகிடும். கார்பன் டை ஆக்சைடு கேஸ் when you cool it and apply lot of pressure, it becomes dry ice, white solid ஆகும். And when it evaporates, it produces carbon dioxide directly. மறுபடியும் கார்பன் டை ஆக்சைடு லிக்விட் வராது. இந்த இதை வந்து அதை ஆட் பண்ணோம். RMgX added to dry ice. You react, the R is polarized. It is nucleophilic. You add to carbon dioxide, it will add to the C double bond O of the carboxylic acid of the carbon dioxide. You form RCO OMgX. This will add to so it will form R O minus, then the Mgx plus will be present. And when you neutralize it with acid, you get RCOH. This is a very important laboratory method. Small quantities lab la வேணும்னாக்க the Grignard reagent prepare பண்ணி add to carbon dioxide. But in the reaction ரொம்ப carefully பண்ணணும். The Grignard reagent has to be prepared with dry ether. கொஞ்சம் கூட வாட்டர் இருந்தாக்க ரியாக்ஷன் சரியாக வராது. Then hydrolysis of nitriles. இது முன்னாடி பார்த்துருக்கோம். RCN ARCN. RCN வந்து ஆல்கைல் ஹாலைடு சோடியம் சயனைடு ரியாக்ட் பண்ணாக்க RCN வரும். இதை வந்து ஸ்பெஷல் மெத்தட்ஸில் ப்ரிப்பேர் பண்ணணும். You must take the amide and dehydrate it. Then you cannot produce directly AR, BR and cyanide, it will not react. We have seen this in phenol chapter also. The nitrile வந்து aqueous sodium hydroxide ஓட ஹீட் பண்ணாக்க it gets hydrolyzed first to amide, then the amide gets hydrolyzed to carboxylic acid. அதை நியூட்ரலைஸ் பண்ணாங்க H3O plus ஓட you get RCOH. அதே மாதிரி the டைரெக்டாக aqueous sulfuric acid 20% heat, you get aromatic acid. In the process, ammonia is released as a gas. Malonic ester synthesis. This compound is called malonic ester. This is produced by reacting malonic acid CH3 COOH with ethanol in the presence of acid. You get two molecules of ethanol condensed with the malonic acid to form diethyl malonate. இதில் வந்து இந்த கார்பனில் குரூப் 2 கார்பனில் குரூப்பு இந்த CH2 குரூப் இதுக்கு நடுப்புற இருக்கிறதுனால இது வந்து இதனுடைய எலக்ட்ரான் வித்ட்ராயிங் எஃபெக்ட்னால இந்த ஹைட்ரஜன் பிகம்ஸ் அசிடிக். இட் கேன் ஈஸிலி ரிமூவ்ட் as a proton. இந்த சோடியம் இத்தாக்சைடோட ரியாக்ட் பண்ணாக்க யூ கெட் திஸ் தி melanate diethyl melanate anion. The counter ion is Na+. இந்த dimethyl melanate anion alkyl halide react பண்ணாக்க you get the alkyl diethyl melanate RCH COO C2H5. இதை வந்து ஆசிடோட ஹைட்ரலைஸ் பண்ணாக்க you get RCH COOH COOH. It's a dicarboxylic acid. இந்த 2 கார்பாக்சில் குரூப்பும் இந்த ஒரு ஹைட்ரஜனோட அட்டாச், இந்த ஒரு CH குரூப்போட அட்டாச் ஆகுது. இந்த மாதிரி ப்ரீவியஸ்லி we have seen OH குரூப் 2 OH குரூப் ஒரே கார்பனில் இருந்தாக்க it will split water, form aldehyde or ketone. இங்கே வந்து 2 கார்பாக்சில் குரூப் ஒரே கார்பனில் இருந்தனாக்க it will lose a molecule of carbon dioxide and form a monocarboxylic acid RCH2 COOH. The other one will remove as carbon dioxide. So this will go like this. இது வந்து நெகட்டிவாக இருக்கும். இது will get protonated to form RCH2 COOH. This will remove as carbon dioxide. Coal base synthesis. இப்போ தான் phenol problemsல we saw this coal base synthesis. ஒரு ஃபீனால் எடுத்துகிட்டு சோடியம் ஹைட்ராக்சைடு போட்டு கார்பன் டை ஆக்சைடோட ஹை டெம்பரேச்சர் அண்ட் ப்ரெஷரில் ஹீட் பண்ணுறது. முதல்ல ஃபீனாலில் சோடியம் ஹைட்ராக்சைடு போட்டாக்க யூ கெட் ஃபினாக்சைடு அயான். இந்த ஃபினாக்சைடு அயானோட கார்பன் டை ஆக்சைடை ரியாக்ட் பண்ணாக்க யூ கெட் திஸ் ஆர்த்தோ ஹைட்ராக்சி கார்பாக்சிலிக் ஆசிட் டை அனயான். இங்கே ஃபினாக்சைடு அயான், இங்கே கார்பாக்சிலேட் அயான். இதை வாட்டரில் நியூட்ரலைஸ் பண்ணாக்க யூ கெட் 2 ஹைட்ராக்சி பென்சோயிக் ஆசிட் which is called salicylic acid. The IUPAC name is 2-hydroxy benzoic acid. It's a very important method to prepare salicylic acid. This large scale prepare பண்ணலாம். The salicylic acid, when you acetylate the OH group, you get acetyl salicylic acid. அதுதான் aspirin medicinal compound. Next we come to the reaction of carboxylic acid with sodium hydroxide. You get the carboxylate anion. With bicarbonate you get carboxylate anion, and you form the other compound is carbonic acid H2CO3. It decomposes to CO2 plus H2O. With NaOH you get directly carbon sodium anion, sodium plus carboxylate anion. The bicarbonate la adhe anion varum, but H2CO3 form ஆகிறதுனால the CO2 H2O they will be coming out as gas, and you will see effervescence, small amount of gas coming out of the liquid. If you treat RCOH, these are reactions of carboxylic acid. If you treat RCOH, sodium hydroxide plus CaO, this is called soda lime. This is lime, this is sodium hydroxide soda. If you distill it at high temperature, you get decarboxylic acid. This CO2 is removed. H will get attached to R. You get RH hydrocarbon plus CO2. Conversion into functional derivatives. We will study these functional derivatives little later. The RCOH, if you react it with SOCl2 or PCl3 or PCl5, any one of these chlorinating agents, these are powerful chlorinating agents, it will convert COOH into COCl. This is the compound. By suitable reagent, this when reacted with the various reagent can form other derivatives. First, this Z is Cl, this is the alkyl, the acyl halide. OR will be ester, you react with ammonia, you will get RCONH2, the amide. This is the ester compound. So, the ester can be prepared directly from carboxylic acid by reaction with alcohol in the presence of acid. This results in protonation of this oxygen. This attacks the carbon, then this OH goes out as water, and R minus R prime OH gets attached to this carbon. This is the ester group. Now, conversion to amides. It has to go through the acid chloride. We have seen how the acid chlorides are prepared. RCOOH plus SOCl2 heat, RCOCl, which is reacted with ammonia, you get RCONH2. Reduction, RCOOH plus lithium aluminum hydride, ether or dioxane as a solvent. These are also very highly water sensitive. You must have dry ether or dry dioxane. கொஞ்சம் வாட்டர் இருந்தாலும் இந்த ரியாக்ஷன்லாம் சரியாக போகாது. RCOOH is reduced to CH2COOH. 2 molecules of hydrogen, H minus, attacks this. One will remove the hydroxyl group, form an aldehyde. The other one will reduce the aldehyde to RCH2OH. The same reaction will take place with diborane, H3B, BH3, to give the alcohol. Alpha halogenation, this reaction was discovered by Hell, Vollard and Zelinsky. This reaction is called Hell, Vollard, Zelinsky reaction. ஒரு alkyl acid எடுத்துன carboxylic acid RCH2COOH reacted the X2, that is halogen, you can chlorine, bromine, iodine with phosphorus. Chlorine and bromine will react much faster. Iodine ரொம்ப ஸ்லோவாக react பண்ணும். X2 halogen plus P, phosphorus is the catalyst, and you get alpha halo carboxylic acid. If you react with water in the presence of acid, this CX bond can be changed to COH. You have 2 hydroxy carboxylic acids. It is a method for preparing 2 hydroxy carboxylic acid or 2 halo carboxylic acid. If you have acetic acid, Cl2P, you get chloroacetic acid. More chlorine, you get dichloroacetic acid. More chlorine, you get trichloroacetic acid. Now, we have seen the reaction of the carboxyl group, the functional group COOH, with the functional group present in an aromatic ring. Substitution can take place in the aromatic ring. The substitution, usually in aromatic ring, you have substituent entering in the ortho and para positions or meta position. So, ortho para orientation or meta orientation. The ortho para orientation takes place when the benzene ring is substituted with electron donating group like methyl group, OH group. These type of groups are acetamino group, NHCOCH3. All these groups which push electron into the ring will make it easy for NO2 plus, the electrophile, to attack the benzene ring in the ortho and para position. If you have electron withdrawing group, then the attack will take place at the meta position. Carboxylic acid group clearly is electron withdrawing group because there is C, double bond O, single bond OH. Oxygen is electronegative, will pull the electrons away from this carbon. This will also pull the electron. That means the benzene ring will have less electron. So, it is meta directing. You will get meta nitrobenzoic acid, reagent concentrated sulfuric acid and fuming sulfuric acid, concentrated nitric acid. mistake here, concentrated nitric acid and fuming sulfuric acid. Now we come to the acidity of carboxylic acid. Carboxylic acid in water is always in an equilibrium with the carboxylate anion and the proton. This proton will be protonating water, you will get H3O plus. This equilibrium at 25 degrees is measured and you get what is called an equilibrium constant. The equilibrium constant வந்து இதனுடைய concentration multiplied by proton concentration divided by the concentration of benzoic acid. This is the value of Ka. The Ka values, the smaller the value, less acidic the carboxylic acid. Here Ka is 6.3 into 10 raised to the power minus 5. If you go to formic acid, where you have a hydrogen attached to the carboxyl group. Here the benzene ring is attached to the carboxyl group. The hydrogen attached to the carboxyl group, the acidity increases to 17.7 into 10 raised to the power minus 5. If you go to CH3COOH compared to C6H5, this is electron donating. As you keep the electron donating groups on the carboxyl group, the acidity will decrease because of the plus I effect of the methyl group. Here as you see, the acidity is only 1.75 into 10 raised to the power minus 5. It is about factor of 4 less than the phenyl group. If you go to substituents on this carbon, if you put 1 chlorine, 2 chlorine or 3 chlorine, chlorine is highly electron withdrawing. That will increase the acidity of the carboxyl group. Now you see now with 1 chlorine the Ka value becomes 136 into 10 raised to the power minus 5. It is a very large factor between acetic acid. It's approximately, let us say it is 2, so it will become around 65 times, and here it is about 6.3. You have to divide by 136 and you get the factor for that. When you have N2, 2 chlorines, it is 5530 into 10 raised to the power minus. The whopping increase of the acidity. When you have 3 chlorines, it almost like mineral acid like HCl, H2SO4, 23,200 into 10 raised to the power minus 5. You can see that as you substitute the alpha carbon with chlorines, the acidity increases tremendously compared to either acetic acid or formic acid. Formic acid is more acidic than acetic acid because methyl group is electron donating. This is usually this is taken as a standard, the value is 1. So this is increased by a factor of 17.7 because there is no electron donation. Now we come to dicarboxylic acid. This dicarboxylic acid, the lowest member is COOH. This is not a formic acid, this is oxalic acid. When you have 2 carboxyl group directly connected to each other. We have seen this malonic acid in diethyl melanate, the ester form. This is the acid form, CH2 group attached to 2 COOH groups. This is 6 carbon, this is 3 carbon, this is 6 carbon dicarboxylic acid, this is adipic acid. So this will be 1,6 hexane 1,6 dihexanoic acid. So this is the adipic acid, and then this oxalic acid can be produced by taking the sodium formate HCOONA. Heating with sodium hydroxide or any other alkaline catalyst, it couples with itself to form this disodium salt of oxalic acid. If you neutralize, you get this. This is also produced, this arrow is wrong, you have to, you heat carbohydrates plus acid, you get nitric acid, you get oxalic acid. The malonic acid is prepared by taking sodium chloroacetate reacting with cyanide ion. This CCl bond is substituted by CCN bond. If you hydrolyze with water and acid, it becomes CH2COOH. If you esterify with 2 molecules of ethanol with H plus, you get diethyl malonate. We have seen its use in synthesis of carboxylic acid. Now you can go to fairly large dicarboxylic acid with large carbon chain by taking diethyl malonate and forming the anion with sodium ethoxide. In the anion, the diiodide CH2N II, so long chain. At the end of it, first carbon has one iodine, the last carbon has one iodine. So just give an example. So this can react. In this case, it will produce 3 CH2, CH2 3 times if it condenses. So this replaces one of the iodine, the other molecule replaces the other iodine. You get a coupling of the 2 malonate with this diiodoalkane. So you can get carboxylic acids, dicarboxylic acid separated by large number of carbon atom. When N is equal to 0, you get this compound. This is called succinic acid. So N is equal to 1, you get this compound. This is called valeric acid, 5 carbon. This is N is equal to 2, called adipic acid. We have seen earlier.